Differentiating terms with fractional indices is quite straightforward because fractional indices follow all the usual rules for differentiating. But differentiating a term that has a surd in it is one step harder. You need to start by turning it into a term containing fractional indices instead, and then follow the usual steps. So I've got a few examples here. We've got the first one, we're differentiating something with fractional indices. The second one has a surd, and the third one is a little bit more complicated, also with a surd. So I've also used three different terminologies for the notation. This one says d dx this, which means differentiate this. The second one, y equals something, so find dy dx, that means the same thing, differentiate it. And the last one has got f of x terminology, so if f of x is something, find f dash x. All of them are asking us to differentiate. So looking at the first one, I can go straight into differentiating this. All I need to do is bring the power down the front, following our usual rule, and then rewrite this part, but instead of x to the power of 3 on 2, I need to take 1 off that. Now, 3 on 2 is 1.5, so if I take 1 off that, I'll just have x to the power of a half. And so I can write that up there like that, and it's finished. Now, don't forget there's a bunch of ways that you could make this answer appear. You could have the 3 on 2 out the front. You could also write it with 3x to the power of half all over 2. That's the exact same thing. You could also convert x to the power of half back into being the square root of x all over 2. Or you could write it as 3 over 2 times the square root of x. Any of those answers would be marked correct. Now, in these sorts of questions, often they'll ask you to leave your answer as a surd or as a fractional index number, so you'll know what sort of format they want, but there's always a little bit of variety. Now, you'll also find that when you're turning your surd into a fractional index number, there's a bit of variety in how you go about it. As long as you're getting the right answer, be aware that you might be doing it different from the person beside you, and both might be fine. So let's have a look at this. First, before I can differentiate it, I need to play with it. So I'm going to start by saying, I'm going to do my working over here, y equals, now if y equals x cubed, all inside of square root, don't forget that that means x to the power of 3, all raised to the power of half. And when we raise a power to another power, what do? We multiply the powers. So this is the same as y equals x to the power of 3 over 2. Now I can go ahead and differentiate just like that one, and I could get the exact same answer. So I could say, all right, dy dx equals, and I bring my 3 over 2 down and have x there and drop my power down by 1. And of course I could express it in all of these other ways. Now, another way to think this through might have been to say, all right, y is equal to, now if I split this up and find some factors of x cubed, I could say it's equal to the square root of x times the square root of x squared. That's just breaking up what I've been given. Another perfectly acceptable way to do it. Now, if you take the square root of x squared, the squared and the square root cancel each other out, and you just have x for this part. So you'd have y equals x, square root of x, times x, wouldn't you? Writing this as a fractional index number, we have x to the power of half times x to the power of 1, and when we multiply and the bases are the same, we need to add the indices. So this person would come up with y equals x to the power of 1.5, which is exactly the same as 3 over 2. It's just a different way of thinking it through. What's the correct way? The way that your brain naturally leaps. So from there, same process really, but if you'd said, all right, dy dx is equal to 1.5 times x, and then you can take 1 off 1.5 to get half. This is a perfectly acceptable way of expressing your answer, but it does look a bit clunky to have a mixed numeral out the front. So if you have expressed your power as a mixed numeral, it's not wrong, but it just looks a little bit awkward to have it as a mixed numeral there. I would at that point then change it and say that's equal to 3 over 2 and use one of these other ways of expressing your answer. They just look a little bit tidier. Now this last question has a trick in it that you might not notice until you do a question like this and get it wrong and have a think about why. Before we tackle this question, let's go back to something that we've already looked at and look at two ways to do things, and then we'll understand why we might be able to mess this one up if we're not careful. If we try to differentiate something that looks like maybe this, then before we start, we actually need to say, well, let's just change our question a little bit, and instead of differentiating that, let's say this is actually 2 cubed times x cubed, isn't it? And 2 cubed is 8. So what we're really differentiating here is 8x cubed. See how I just expanded the brackets there so that I had a simple constant out the front? And then the only thing that was raised to the power of 3 was the x. Whereas over here, the whole 2x is raised to the power of 3, and that's not the same thing. Okay, now have a look at what would happen if I did it each way. So differentiating this is quite simple. I just say, bring the 3 down the front, multiply it by the 8, and I get 24x, and I reduce the 3 to a 2. And this is the correct answer. But if I hadn't expanded the brackets first, have a look at what would happen if I just said, bring the 3 down the front, and multiply it by 2x, all to the power of 2. I've now got here 2x all squared. Well, that's 4x squared, isn't it? So that would give me 3 times 4x squared, which is only 12x squared. And that is not the same answer as this one. So clearly, to get this right, I actually need to expand brackets first and make sure the only thing that I'm differentiating as a power of x is x itself. I can have a constant out the front, but that constant can't also be raised to the power. So thinking this through then, as we're going to tackle this question over here, we need to be careful with this 4, because it's been raised to this same power here. Now the easiest way to deal with it is to break it up first. So let's start with our question. We've got 1 over that. Now I haven't differentiated it yet. This is still f of x. So the first thing I'm going to do is modify it a little and say this is the same as 1 over the square root of 4 times the square root of x, isn't it? So I've just broken up the factors there, 4 times x. Now I've done that because I know that the square root of 4 is 2, so that's something I can easily find. So again, showing all my working, normally there's parts of this I might do in my head, but to make sure I don't mess up and to show you what I'm doing, I'm going to do every step. So I've now got this. Now don't forget this is exactly the same as a half times 1 over square root of x. So if I now want to change my x into a fractional index number, then I need to bring it up the top of the fraction. And I know that x to the power of half is the square root of x. So I know I need x to the power of half, but I also need x to the power of negative a half, because that will bring it up to the top. And I know that I need all my powers of x to be up the top of a fraction to be able to differentiate them. We looked at that already when we examined negative indices. So I've got basically a half outside of x to the power of minus a half. Now, I've written it like this with the half out the front, so it's really clear that I've now got a constant out the front, and then I've got x to the power of something. So I'm ready to differentiate it. It's nice and simple. You could always write this as x to the power of half all over 2. It means the same thing, but I quite like having that constant out the front just to remind me that it's separate. Okay, now I'm ready to differentiate. So I can write f dash x now. Now the same rules that we've been using apply, so I take my minus a half and I bring it down the front and multiply it by a half. Now half times half is a quarter, and it's going to be negative a quarter. Then I rewrite my power of x, but I have to take 1 off the index number. So instead of x to the power of minus a half, it's going to go down by 1 and be minus 1 and a half. And I'm going to write that as minus 3 over 2, because I like the use of that improper fraction there. It means that I can easily rewrite this as a surd if I want to. Now they've given me the question with a surd, so a lot of the time in these questions, they actually ask you to find this as a surd. Let's pretend that we have. Let's find it as a surd. So now I need to just fiddle with this expression to get it looking like a surd. So f dash x equals, now if it's to the power of minus something, that means the x needs to go back downstairs. So on the top I've got minus 1, or I could just put a minus out the front and put a 1 here. And on the bottom I've got 4, and I've got x to the power of 3 over 2. Now that means x cubed, all inside a square root. And that's a perfectly acceptable way of doing this. It has perfectly good meaning. Don't forget we've already seen that x cubed, all inside a square root, is the same as x times root x. So it wouldn't be wrong to write it as minus 1 over 4x root x. Which one's better? Well, whichever one you've come to first, really. Either of them is acceptable as a finished answer.